So in this video, we're going to continue to use the half-angle identities to work on problems. So for example, suppose the cosine of alpha is equal to 12 over 15 and 3 pi over 2 is less than alpha is less than 2 pi. Find the exact values of the sine of alpha over 2 and the tangent of alpha over 2. So before we even go about finding the values, the first thing I want to do is basically draw a picture and figure out where alpha is. So they give us some information. They tell us that alpha is between 3 pi over 2 and 2 pi. So if you remember, that means it's an angle here someplace in the fourth quadrant, because here's 3 pi over 2 and here is 2 pi. So we're sitting someplace in there. And so if I were to draw my reference triangle, it's going to look like that. And I know the cosine is 12 over 15. So this side here is going to be 12, the adjacent, and the hypotenuse is going to be 15. And then what I have to do is use the Pythagorean Theorem to find the missing side. So a squared plus b squared equals c squared. So 12 squared plus b squared is going to be 15 squared. So 12 squared is 144 plus b squared equals 15 squared is 225. If I subtract the 144 from both sides, b squared is going to turn out to be 81, which means b is equal to plus or minus 9. And then if I come over here and I look, I'm going down, which means I'm going to have to take that negative 9. So now I have my triangle set up. The next thing that I want to do is actually figure out what we're going to find. So this first one, the sine of alpha over 2. So remember, the half-angle identity for the sine of alpha over 2 is going to be plus or minus the square root of 1 minus the cosine of alpha all over 2. So in this case, our original angle was between 3 pi over 2 and 2 pi. So since alpha is between 3 pi over 2 and 2 pi, remember I'm looking for alpha over 2. So if I divide each of these by 2, that tells me that alpha is between alpha over 2 is between 3 pi over 4 and 2 pi, and pi. Oops. And pi. So 3 pi over 2, things between 3 pi over 4 and pi, that's actually in quadrant 2. So in quadrant 2, the sign is positive, so we're going to take the positive case. And so this is going to be positive, the square root of 1 minus. The cosine here of alpha is going to be 12 over 15 all over 2. So in this case, it's going to be, so if I work that out, it's the square root of 15 over 15 minus 12 over 15 all over 2. Erase part of this here, which would end up being the square root of 3 over 15 all over 2. And so 3 over 15 is really, clean that up here a second. So 3 goes into both of those, so it's really the square root of 1/5 all over 2, or the square root of 1 over 10. And then tangent's actually easier because we can use the formula that doesn't have a plus or minus. So the tangent of alpha over 2 is 1 minus the cosine of alpha all over the sine of alpha. So in our case here, it's going to be 1 minus 12 over 15 divided by negative 9 over 15. So probably the easiest way to deal with this would be to multiply the whole entire equation by 15 over 15. So I haven't changed anything. So this is going to be 15 minus 12 all over negative 9. Or 15 minus 12 is 3. So 3 divided by negative 9, or negative 1/3. So you just have to be a little methodical about them. So we'll do another example. B. So this time we're given that the cosine, not the cosine, the tangent of theta is equal to negative 12 over 5. And theta is between 90 degrees and 180 degrees. So again, they're talking about being in, so 90 to 180 is somewhere here in the second quadrant. So we're talking about over here. And if I drop down my reference triangle, so this part's theta, so remember this is theta prime. And so the opposite is negative. So the opposite is 12. Should be a little careful here. So the opposite is 12 and the adjacent is 5. And then one of them has to be negative because the answer is negative. And since I'm going to the left, it's the 5 that's actually negative. So if I use Pythagorean Theorem, a squared plus b squared equals c squared. So 12 squared plus, negative 5 squared equals c squared. So 144 plus 25 equals c squared. So c squared is going to be 169. So c is going to be plus or minus the square root of 169. Or c would be plus or minus 13. And it's the hypotenuse, so it's going to be the positive, so it's just 13. And I didn't tell us what we're trying to find here. I should have said that. Find an exact value for the cosine of theta over 2. So again, my original angle, my theta, is in quadrant 2. I'm going to divide everything by 2, and that's going to tell me where theta over 2 is. So 45 degrees is less than theta over 2 is less than 90 degrees. So that tells me quadrant 1. So our formula, cosine of theta over 2, is going to be plus or minus the square root of 1 plus the cosine of alpha all over 2. So since here I determined that theta over 2 is in quadrant 1. In quadrant 1, the cosine is positive, so our answer is going to be positive. So we're going to have the square root of 1 plus, so the cosine would be minus 5 over 13 all over 2. And again, I can multiply the top and bottom by 13. So we're going to get the square root of 13 minus 5 all over 26. And then 13 minus 5 is 8. So we have the square root of 8 over 26. And I can reduce that to the square root of 4 over 13. But remember, we know the square root of 4, it's 2. So this is going to be 2 over the square root of 13. That's pretty much all there is to this objective.